And determination of primary structure. How you determine the particular primary structure of a particular protein, okay, and what is the importance in determination, okay, and this is very important, okay, to determine the quality and quantity, okay, and know the sequence of amino acids in particular protein. And determination of how you will define, I mean, three stages determination is there. Know the sequence of primary structure. First is amino acid composition, that means what are the types of amino acids involved in the formation of primary structure, okay, and degradation of protein, okay, and once you break the primary structure by using like hydrolytic enzymes into small fragments, okay, and the third one is determination of amino acid sequence. That's what I was telling. Determination of amino acid composition, degrading the protein into smaller peptides, and amino acid sequence determination. And the protein or a polypeptide which is completely hydrolyzed to liberate amino acids. So remember, whenever you want a amino acid, protein has to degrade to polypeptide, and this polypeptide has to degrade into amino acid. Okay, and this hydrolysis has to be carried out either by acid or alkali treatment or by enzyme hydrolysis. Okay, otherwise it is very difficult to break a peptide linkage. And pronase is a mixture of non-specific proteolytic enzymes, okay, which are involved in complete hydrolysis of proteins. Separation and estimation of amino acids. The mixture of amino acids which are liberated by protein, okay, hydrolysis, that can be determined by chromatographic techniques. There are different chromatographic techniques like thin layer chromatography, paper chromatography, gas liquid chromatography, okay, and high density like high performance liquid chromatography, HPLC. So all these types of chromatographies can be utilized to know the sequence or composition of amino acid in a primary structure. And degradation, so like liberation of polypeptides, treatment with urea or guanidine hydrochloride, and which is disturbing the non-covalent bonds and dissociates into the protein and to the polypeptide units. Okay, the cleaving of disulfide linkage between the polypeptide units. Okay, how it is possible? By treating that particular polypeptide by using performic acid is must. Number of polypeptides. So how you define, I mean, like how you come across that particular protein is made up of number of polypeptide chains. Okay, the number of polypeptide chains which can be identified by treating that particular protein with dancyl chloride, okay, and it is going to specifically binding with the N-terminal amino acid and forms the dancyl polypeptides, which on hydrolysis yield N-terminal dancyl amino acids. That means each peptide is having only one N-terminal. Okay, I already told you proteins are made up of few proteins. Okay, few proteins may be made up of single polypeptide, and few proteins may be made up of more than one polypeptide. So to know how many peptides are present in the protein, this method is useful. That means by treating that particular protein with dancyl chloride, as dancyl chloride is going to react with the N-terminal of particular peptide. Okay, so after hydrolysis, each dancyl chloride is going to attach to each N-terminal end. That means if you found how many number of dancyl amino acid, N-terminal dancyl amino acid, that many polypeptides are present in the protein. Okay, and breaking of polypeptides into fragments. Polypeptides are degraded into smaller peptides by enzymatic or chemical methods. Enzymatic cleavage like proteolytic enzymes such as trypsin, chymotrypsin, pepsin. So these are all enzymes which are present in the digestive system. Okay, and elastase which exhibit the specific cleavage of peptide bonds. That means trypsin will be cleaving the polypeptide at particular amino acid. Okay, and chymotrypsin is having particular amino acid sequence where it is going to cleave the polypeptide. Okay, like this all these proteolytic enzymes will work. Okay. Among the enzymes, trypsin is a commonest form to use for breaking down of polypeptides. Trypsin hydrolyzes the peptide bond containing, as I mentioned, trypsin hydrolyzes a polypeptide, okay, which are containing lysine or arginine to the carboxylic site of the peptide linkage. Okay, and chemical cleavage by using cyanogen bromide, okay, we can cleave the peptides. Okay, cyanogen bromide specifically splits the peptide bonds, okay, at the carboxylic side of which is contributed by methionine. And how to determine the amino acid sequence? Okay, Sanger's reagent, okay, and it is mix up of 1-fluoro-2,2,4 dinitrobenzene. That means the 2 and 4 place there is a nitrobenzene ring. Okay, 1-fluoro-2,4 4-dinitrobenzene. This is called as Sanger's reagent, and this is the most commonest reagent to elucidate the structure of insulin. Okay, and what it will do, this 1-fluoro-2,4-dinitrobenzene specifically binds with the N-terminal amino acids to form dinitrophenyl derivative of peptide. Okay, what it forms? Dinitrophenyl derivative of peptide. Okay, and once this dinitrophenyl derivative of peptide form, okay, it has to undergo hydrolysis and it forms DNP amino acids. Okay, what it forms? It forms DNP amino acids and free amino acids. Okay, from the rest of the peptide chain. Like this, you can know the sequence of the amino acids. And DNP amino acids, which can be identified by chromatography. Yes, different chromatography is based on the, their solubility. Okay, how they are going to be soluble in particular solution and how they travel, okay, by using the solubility, right? So after you are getting DNP amino acids, by performing the chromatography, you can assess which type of amino acid is present in the particular sequence. Okay, and Sead's reagent is a combination of phenyl thiocyanate, okay, and which is also reacting with the N-terminal amino acid of peptide to form phenyl thiocarbamyl derivative. Okay, on treatment with mild acid and phenyl thiohydrodentine amino acid is cyclic compound liberated. And PTH amino acid, which can be identified by chromatography. Okay, and compared to previous, okay, Sanger's, this Sead's reagent is having advantage. Okay, a peptide can be sequentially degraded and liberating N-terminal amino acids. After that, which can be identified. This is due to the fact that peptide as a whole, okay, which is not hydrolyzed but only releases, okay, what is that? PTH, okay, phenoxythiohydroxycarbamide amino acid. And sequenter, that means the automatic machines which can easily, it's it's not a time consuming one. Okay, with this help of machine, you can easily identify the sequence of amino acids in a polypeptide. Okay, it is also working on the principle of Sead's degradation. Okay, amino acids are determined sequentially from N-terminal end. So as we are all aware, polypeptides having two ends, right? One is amino terminal end, other one is carboxy terminal end, right? So this sequenter easily counts the amino acids, okay, from N-terminal end. Okay, and PTH amino acid liberated identified by HPLC. HPLC stands for high performance liquid chromatography. Okay, and sequenter, which is taking about 2 hours to determine each amino acid. Okay, it is a time consuming. Okay, though it is an automatic machine, it is a time consuming. That means single amino acid can be detected by using the time duration of 2 hours. And overlapping peptides, that means the determination of primary structure of protein. Several methods are simultaneously applied. Okay, one such method is overlapping peptides. Okay, overlapping peptides are very useful in determining amino acid sequence. And reverse sequencing technique, that means if particular amino acid is running in one direction, okay, this reverse sequencing will be used to similarly in genetic material DNA, which ultimately determines the sequence of amino acids in a polypeptide chain. Yes, central dogma of life. DNA forms RNA, RNA forms protein. Ultimately, the information in the DNA get established in the protein, right? So by analyzing the nucleotide sequence of DNA that code for a protein, it is possible to translate a nucleotide sequence which is coding for amino acid, right? And this technique, however, fails to identify disulfide bonds because there is no facility to identifying disulfide bonds. That means the changes which are occurring in amino acids after protein synthesized.